Okay, so kahit walang tao, let's start. Make the recording for this week 7 lecture so that you guys will be able to have something to picture on. Let me share my screen. Start broadcast. All right, so what we're going to tackle now is the auto cycle or yung four-stroke cycle na pinag-usapan natin previous weeks. We're going to have the thermal analysis of an ideal auto cycle. So this is an auto cycle. So we have your pressure volume diagram or your PV diagram. So let's take a look at take a quick look on how does it goes. As you can see, there are four strokes or yung four stages of the combustion process. Each stroke, you will be able to see where the ball goes, kung nasan siya, how it is plotted at the PV diagram. So we will analyze each step in each process on this PV diagram. This is the PV diagram. The auto cycle or the four-stroke cycle is sometimes referred to as a constant volume combustion. So as you can see, yung volume at process 1 to 4 at yung process 3 to 2, constant yung volume niya, same volume. Whatever with energy in is energy out, volume in is equal to volume out. So yun yung principle na ginagamit natin. So let's see. First, from process 1 to process 2. Yung process 1, we will define it as the intake. And process 2 is the first compression process na nangyayari sa atin. So yung process 1 where there's no from 1 to 2, yung point 1, there's no air fuel mixture inside the chamber yet. And sorry, the air and fuel mixture are going inside the combustion chamber. So that's process 1. The intake of the air and fuel mixture, that's process 1. Process 2 is the compression of that air and fuel mixture. So the process from point 1 to point 2 or process 1 to 2 is called the isentropic compression. Process 2 to 3, where the air and fuel mixture is compressed and spark is introduced, kaya meron tayong heat addition. This is where the combustion takes place at high pressure, low volume. So, pinipit mo na siya, pinompress mo na yung air and fuel mixture, and while it is compressed at high pressure, nag-introduce ka ng heat, which is yung spark. And with this heat, nagkaroon ka ngayon ng combustion process. Process 3 to 4 is called the isentropic expansion. So because of the combustion process, you had a rapid expansion of your gas fumes. And this expansion pushes the piston to go down and in turn increases the volume. This is where the chemical energy of the combustion process is converted into a mechanical energy. That's why we call it as a power stroke. So this process from point 3 to point 4 is called the isentropic expansion. And last but not the least, yung heat rejection. This is where the the volume of the exhaust of the combustion process, yung byproducts niya, is being exhausted out sa makina. Okay. Balik tayo dun sa sinabi natin sa process 1 to 2 saka process 3 to 4. Isentropic expansion and isentropic compression. Ano ba ibig sabihin ng isentropic compression? Isentropic means it's reversible and adiabatic. Adiabatic means there's no heat gain or lost within the system. So when you are going from point 1 to point 2, there is no heat gained, and when you're going from point 3 to point 4, there is no heat loss. Since we are a constant volume process, yung volume at point 2 and volume at point 3 is equal. Kaya vertical yung line niya. Same goes with volume at point 1 and the volume at point 4. It is also equal. Next. So, yung ano natin, no, yung volume, yung process natin from point 1 to point 2 is the isentropic compression. Yung process natin from point 2 to point 3 is heat addition. Ito yung introduction of spark. Yung process natin from point 3 to point 4, this is yung expansion or isentropic expansion. This is where the power stroke, where the combustion energy, combustion process, the energy harnessed in the combustion process is in turn converted into mechanical energy. At yung process from point 1 to point 4 to point 1 is called heat rejection. Ito naman ngayon yung umaalis na, yung exhaust natin. So, since there's no heat addition, since there is no work done in process 2 to 3, meron tayong heat intake pero wala tayong work done because there's no change in volume, there's no work done. Pwede nating sabihin na work is equal to 0. So, the amount of heat, Q, heat addition natin, Q in is equal to the CV times T3 minus T2. Yung temperature at point 2 minus the temperature at point 3 times its specific volume. The specific volume of the air and fuel mixture. Specific volume times yung difference in temperature is equal to the heat intake or heat introduction. So it will also be the same doon sa process 4 to 1. Kabaliktaran lang. So doon sa process 4 to 1, since na walang change in volume, meron lang tayong heat rejection o yung exhaust natin. So the heat rejected is equal to the specific volume times the difference in temperature between point 4 and point 1. Okay. Let's analyze naman yung point, process 1 to 2 at saka process 3 to 4. Doon sa doon sa Q in at saka sa Q out natin. So heat addition at saka heat rejection natin. Because of the process 2 to 3 and because of the process 4 to 1, we're able to calculate yung amount of heat introduced and amount of heat rejected. The difference or the ratio of the introduced heat to the exhausted out heat or heat rejected is called the efficiency. Ito yung thermal efficiency. Okay? Since na doon sa Q in natin at sa Q out natin, parehas tayo ng substance na ginagamit, yung air-fuel mixture, constant specific volume ng air-fuel mixture, we can cancel that out. And we are left with efficiency is equal to 1 plus T1 minus T4 over T3 minus T2. Using the PV is equal to, using the ideal gas law, PV is equal to MRT. Yung T1 saka T2, pwede nating igawing V2 saka V1 times or raised to the ratio of the specific pressure and specific volume. Okay? So, using to convert yung temperature, yung ratio ng temperature at saka to convert yung ratio ng temperature into volume, we will be using yung K. Yung K is yung ratio ng specific volume at saka specific pressure. So T1 over T2 is equal to V2 over V1. Sorry, mali na ako. Ayun. T1 over T2 is equal to V2 over V1 raised to K. Next. Kung mapapansin naman natin ngayon, kapag kasi substitute natin yung T1, T2, tsaka T3, T4, using yung volumetric conversion niya, the efficiency would be left with 1 minus 1 over R raised to K minus 1. Yung R is yung compression ratio, where V1 over V2 or yung TDC over BDC. Okay? Okay. So, tignan ko lang ulit. Meron ba tayong estudyante ngayon? Wala. Walang estudyante ngayon. So, I'll continue. I'll continue with sample problem. Sample problem tayo. An ideal air standard Otto cycle engine has a compression ratio of 8. At the beginning of the compression process, the working fluid is at 100 kilopascal and 27 degrees Celsius and 800 kilojoule per kilogram. Sandali lang. Okay, continue tayo. Sandali lang ha. Okay. 800 kilojoule per kilogram heat is supplied during constant volume heat addition process using the specific heat values of air at typical average cycle temperature of 900 Kelvin. Determine three things. First is yung temperature and pressure of each cycle at each point of the cycle, and yung network output at yung thermal efficiency. So let's continue. So ito yung ano natin, ito yung given natin, ito yung problem natin. Let's see kung ano-ano ang meron ano-ano ang meron sa given natin. So first, yung sinabi dito, compression ratio. So at the compression ratio, makikita natin, we have compression ratio is equal to V max over V min or V1 over V2 or V4 over V3. Tapos binigyan na sa atin yung compression ratio at 8. Also given to us is yung heat addition natin. Heat is supplied, so heat addition, so that's the process between 2 and 3. Okay? Next, binigay din sa atin yung starting point, starting pressure, temperature. Yung volume binigay based on compression ratio. So meron tayong pressure at 0.1 at meron din tayong temperature at 0.1. Binigay din yung CV. So based on ideal gas specific heat capacity, CV, na at 900K. So search natin yan si Google at 900K, ano yung specific ideal gas specific heat value, which would give us at 1.344. So with that, with this given, we were able to compute the pressure, ano ba hinahanap niya? We will be able to compute the temperature and pressure of air at each process. So first, from point 1 to point 2. Point 1, meron na tayong pressure, 100 kilopascal. Point 2, meron na tayong, point 1, meron na tayong temperature at 300 Kelvin. So using yung adiabatic process natin, where P1 over P2 is equal to V2 over V1 raised to K, or using yung temperature variant niya, V2 over V1 raised to K is equal to T1 over T2 raised to K divided by K minus 1. So using this formula, may extract out natin kung ano yung value ng T2. Meron kang V1 over V2, yun yung compression ratio mo. Meron kang K, yun yung specific heat capacity mo. Meron ka no T1, which is given at 300K. So using this, you'll be able to calculate roughly around 613 yung T2 mo. So meron ka ng T2. Using the same formula, makukuha mo naman yung, using your ideal gas relation, PV is equal to MRT, where your M and your R are constant because it's the same substance. Constant volume. So yung M mo, yung amount of mass mo is the same. So using PV is equal to MRT, yung P2V2 over T2 is equal to P1V1 over T1. Meron kang P1 tsaka T1. Meron kang T2. Wala kang P2. Pero yung V1 tsaka V2 mo is, again, compression ratio. So you'll be able to calculate for P2, which is 1,635 kilopascal. Next. Yung process mo from point 2 to point 3, where work is equal to 0, pero Q mo meron. So sinabi natin kanina, Q is equal to the specific heat capacity times the difference in temperature. Meron ka ng temperature in, meron ka ng temperature out. Pero, yung Q mo is equal to 0. Yung dito, mali pala ako, hindi pala ito process 2 to 3. Ito pala ay process 1 to 2. Process 1 to 2, merong makakalculate mo yung work. Yung formula natin parehas, Q minus work is equal to change in U. Change in, entropy. Pero since na meron kang change in volume, meron kang work. Wala kang Q kasi meron kang work. So Q is equal to 0. You did not introduce any heat. So using this formula, you'll be able to determine kung how much work was produced during the process 1 to 2. And work is equal to about negative 261 kasi pasok pa siya. Siya para yun yung nagtatrabaho. So, balik naman tayo sa point 2 to 3. Ito naman, kabaliktaran nung kanina. Kanina, Q is equal to 0. Now, Q has a value and work is equal to 0. So, ayan. So, 2 to 3, meron ka ng specific heat capacity given. Yung T2 mo, calculated from previous process. Yung heat at point 2 to 3 is given. It is given at 800 kilojoule per kilogram. So given siya doon sa problem natin, no? And with that, we'll be able to calculate yung temperature at point 3, which would be about 1,500 Kelvin. So let's go to process 3 to 4. Process 3 to 4, again, ayan, using yung PV is equal to MRT, meron kang P3 na calculate natin. Ika-calculate natin. Meron tayong V3 tsaka V2. V3 tsaka V2 is parehas. Same volume, so canceled out. Naiwan na lang sa'yo yung T3 tsaka T2. So P3 will be equal to about 4,000 kilopascal. So next, from point 3 to point 4. Again, adiabatic process. Constant ideal gas law. Ito yung PV is equal to MRT converted from temperature to volume. So dito, given na sa yung volume at 4 and volume at 3. Yung volume at 3 and 4 is still equal to the compression ratio. So compression ratio raised to the specific heat nung substance mo at 900 K, which is 1.344 minus 1. So calculated mo na yung T3 from the previous process. So T4 can be calculated. And T4 is about 769 Kelvin. Next, from your PV is equal to MRT, ideal gas law again. Meron ka ng P3, meron ka ng P4. Meron ka ng P3, wala ka pang P4. Meron ka ng T3, meron ka ng T4. Yung ratio ng V3 tsaka V4 again is your compression ratio. So P4 can be calculated at 256 kilopascal. Work. So there's change in volume, so there is work. Work can be calculated again by the difference in temperature times the specific heat. So paulit-ulit lang yung ano natin, no, yung formula natin. So work at 4 is equal to 670 kilojoules. And from point 1 to point 4, again, ito ay constant volume process. Meron ka ng temperature at 4, meron ka ng temperature at 1, at meron ka rin specific heat capacity at 900 Kelvin. So you will be able to calculate how much is the heat rejection. Heat rejection is equal to, ayan, calculate the heat rejection. Heat rejection is equal to 391 kilojoules. So first, nakuha natin, first question is the temperature and pressure of air at the end of each process. So na-calculate natin yung temperature at saka yung pressure ng air at points 1 to 4. Ang susunod na question ay net work output. Ang net work output is the sum of all work. Remember, at point 1 to 2, meron kang negative work. At point 3 to 4, meron kang positive work. What is the total amount of work given? So you have to sum those things up. So network output cycle, meron tayong work at, the amount of work is equal to the amount of heat. Q net is equal to work net. So kanina, meron tayong 800 kilojoules plus yung 391 natin, na-calculate kanina. Ang Q net natin is 409. Kung yung Q net is equal to work net, so dapat parehas din. Yung work na nakuha natin kanina, ayan, is 261. Tapos yung isa, yung workout natin sa point 3 to 4 is 670. Pag pinag-add mo sila, ang sagot pa rin ay 409. Oops. 409. 409. Malapit nang matapos. So last is yung thermal efficiency natin. Yung thermal efficiency natin, sabi natin makukuha natin yung sa ratio ng input tsaka output heat. So ang input natin is 800 kilojoules, ang output natin is negative 391. So Q net over Q in. Ano ba yung Q net natin? Q net natin is 800 minus 391 is about 409, di ba? Ito yung kanina, 409. Oh, sorry, Q. Ayan, 409 kilojoules per kilogram. Ang Q net natin divided by 800. So our thermal efficiency is approximately about 51%. Same kapag ginamit natin yung ganitong formula kanina. So sinabi natin, di ba, pag nag-derive tayo, lumalabas. Ang formula natin is 1 over T1 divided by T2. So if we do these things, or these things also, this formula, using yung compression ratio, we will still get, not exactly, but approximately same, 51%. Okay? All right. Thank you very much. Wala tayong tao ngayon. So, I will stop. Maraming salamat. Thank you very much.